Hi everyone, Mrs. Below here. In this video I'm going to go over the second question in the titration worksheet. So again, the first thing you want to do is make sure that you are figuring out the concentration of the known first. So in this scenario, we have 81.7 milliliters of a 1.34 molar solution of HNO3. So the known then is going to be our HNO3. So this is the known. We know the concentration of that. And we have to first find the moles of the known. Now it's important to remember to disassociate to make sure that you know the concentration of the known, in case it's like the first problem here where when you disassociated you got a 2 with the OH, which had to be taken into account. So HNO3, if we disassociate this, we get the H, which is +1, and NO3, which is -1. There is one of each. So that concentration, the 1.34 times 1 is still going to be 1.34 of our HNO3, which is our known. Now again, we're trying to find the moles of the known. So moles, remember, is equal to molarity times liters. So we just found the molarity, that was 1.34, times the liters. So we had 81.7 milliliters of that known. If we convert that into liters, moving the decimal 1, 2, 3 to the left, that'd be 0.0817 liters. So 0.0817 liters. So we're going to multiply those together. So 1.34 times 0.0817 is 0.109478. So this is how many moles of the known we have, which is HNO3. The second step is going to be to find moles of the unknown. And in order to do that, we have to write out the full reaction for this neutralization reaction. So we combined HNO3 with the base this time is our unknown solution, which is LiOH, lithium hydroxide. Again, this is a neutralization reaction, so you're always going to get water as one of those products. So again, this water is forming from this OH from the base and this H from the acid. So whatever you have left over is going to form the other product, which is your salt. So we have left over Li and NO3. So Li is +1. NO3 is -1. If we do the crisscross, the formula will still be LiNO3. And in this case, we actually don't have to do any balancing. This reaction is actually already balanced, but I'll point out all of those things. So we have, right, the H. Remember, those two things form the water. There's two H's and the O. So we have the same amount of H's and O's on either side. There's one NO3 on either side and one lithium on either side. So we still want to show the picket fence though for converting the moles of HNO3, which is our known, into moles of the unknown. So again, according to this, there's ones in front of everything. We just don't write them because they're placeholders. So we have 1 mole according to the balanced equation of HNO3, and 1 mole of LiOH. This is the unknown base that we're trying to find the concentration of. So in this case, we will get the same number, okay, of moles of each, just because of how the equation balanced out. So now we have the moles of the unknown solution. So then the last step is to find the molarity, right? Molarity is moles divided by liters. So we just calculated the moles of the base LiOH, and then we need the liters. So according to the question, there were 56.3 milliliters. So if we have 56.3 milliliters, if we want to convert that into liters, we have to move 1, 2, 3 to the left. That's 0.0563 liters. And then we're going to divide those two numbers, 563, to get the concentration of our unknown solution, which was LiOH. So 1.9, 4, and then this 4 is going to round up to a 5. Well, that's the molarity of the unknown, which in this case was the base.